All right, we're looking at finding polynomials when given solutions to the polynomial. Okay? Like right here. Suppose x equals 5 is a solution to a polynomial, and x equals -3 is a solution. These are solutions. So that's a solution. That's a solution. All right, so since x equals 5 is solution, that tells me that x minus 5 is a factor. X minus 5 is a factor of the polynomial. And since x equals -3 is a solution, then that tells me x plus 3 is also a factor. And so now to find the polynomial, I just multiply my two factors. So we can do this with FOIL method, multiplying this up, but I like using the box right here. We'll just use this box. I build this box. I got x minus 5. I got a column for the x. I got a column for the minus 5. And then the x plus 3 goes to this side, and I got a row for the x, and I got a row for the plus 3, which gives me these four products, which is what your FOIL method does. But this just organizes it for you. So like right here, this is x squared. X times -5 is -5x. X times 3 is 3x. And right here, -5 times 3 is -15. And so these two are like terms. I've got x squared. I've got -5x plus 3x, which is -2x. And I got -15, and there's my polynomial right there. Okay. Now, suppose I have x equals 1/2 and x equals 3/5. Suppose I have fraction exponents, fraction solutions. This is a solution, that's a solution. Well, that tells me right here, since that's my solution, x minus 1/2 is a factor. Now, normally we don't have fractions in our factors, so what I do is I multiply both of them by 2, which gives me this factor right there. Okay? And now right here, I tell you what, let me change this to negative so you can see a negative involved in here. Okay? So there's my solution there, -3/5, which means x plus 3/5 would be my factor, but normally we don't have fractions in our factors, so I'm going to multiply both of these by 5, which means I'll have 5x plus, and then 5 times that would be 3. And there you go, there's my factors. That's why I just multiply them. You can do FOIL method, but I'm going to do a box. I got a column for the 5x, I got a column for the 3. It doesn't matter which one's on top as long as you have, use both of them. Then I got a row for the 2x, and then I got a row for the -1. And there you go, right here, 5x times 2x, 10x squared. 2x times 3, 6x. 5x times -1, -5x. 3 times -1, -3. These two are like terms, and so here you go. 10x squared, 6x plus -5x would be a plus 1x, and then I got -3, and there you go. There's my polynomial with these solutions. Okay? If you put 1/2 in, let's see if I can do this. 1/2 squared would be 1/4 times 10 would be 10/4 plus 1/2, which is 2/4, -3. And then 10/4 plus 2/4 is 12/4, which is 3. -3 is 0. So 1/2 works. -3/5 work too. I would say I'm not going to spend my time doing that. Okay, now, what if you have radical answers? Like what if x equals 3 plus radical 5, and then x equals 3 minus radical 5? All right, suppose you have these radical solutions. All right, well, same thing. If that's my solution, that means my factor is going to be x minus this stuff, which means it's x minus 3 minus radical 5. And then here I've got x minus those, which is -3, and then plus radical 5. And there's my factors, and I just multiply them. Now, when I do this, there's 3 things and 3 things, which means that when I build my box, I've got a column for each one of those, and I'm going to have a row for each one of these, which gives me 9 products. Now, usually, these are conjugates, and usually when you do conjugates like this right here, see, we got 3, and you got radical 5, one's plus and one's minus. You got the same terms but different signs between them. usually these two squares and those two squares will cancel every time. And so usually I don't even worry about them, but I'll show you that they cancel here. But normally I just don't even bother with those squares. But right here, x times x is x squared. X times negative 3 is negative 3x. And x times radical 5 is x radical 5. All right, right here, negative 3 times x, negative 3x. Negative 3 times negative 3 is a positive 9. Negative 3 times radical 5 is negative 3 radical 5. Okay, down here, x times negative radical 5 is negative x radical 5. And see, that cancels this one. Those are opposites, they cancel. Right here, negative 3 times negative radical 5 is a positive 3 radical 5, which cancels this one. So see, these always cancel when you have conjugates like these are. And if they're not conjugates, you got to do them all. And then this last square, I got radical 5 times negative radical 5, which is negative radical 25, which is 5. So negative 5. And now you just put your like terms together. So I got an x squared. I've got negative 3x and negative 3x, which is negative 6x. And I got 9 plus negative 5, which is 4. And there you go. There's my polynomial that has these zeros, or those solutions. Okay. Now, one more. Suppose we have imaginary solutions. Like suppose x equals 3 plus 2i, and x equals 3 minus 2i. Suppose these are solutions. Well, just like the previous problem, since this is my solution, that means my factor is going to be x minus 3 minus 2i. And if that's my solution, the factor will be x minus 3 plus 2i. And I multiply these together, which these are conjugates again. These are conjugates. So when I build my box, I got a column for each one of these, and I should have a row for each one of those. So here's x, here's negative 3, here's negative 2i, and there's 9 products. And again, these two squares and those two squares, I don't really worry about them, but I'm going to go ahead and do them and show you that they'll cancel again. But this is x times x, negative 3 times x times 2i would be 2xi. Right here, negative 3 times x, negative 3 times negative 3, negative 3 times 2i, and negative 6i. And then right here, x times negative 2i is negative 2xi. Negative 3 times negative 2i would be positive 6xi. And then right here in this one, all right, this is negative 2i times positive 2i, which negative 2 times positive 2 is negative 4, and it's I squared. And of course, I squared is negative 1. So that's a positive 4 in that square. Okay? And now look, see these two? They cancel. And those two there cancel. Every time they will, if these are conjugates going in the squares. So I have an x squared. Okay? I've got negative 6x. And I got 9 plus 4, which is 13. And there you go. There's my polynomial with those solutions. So that's how you find polynomials when you're given solutions. All right, so if you need additional help, just yell at me. All right? I'll help you all I can. So have a great day.